Hello, everyone. I think we should be live. Give me 1 second to get set up here. Cool, and I already see some people are watching. It's always good for me to double check just to make sure you can hear me and see me, and I'll go ahead and share my screen as well. And if you want to let me know in the chat that you can hear me, that'd be great. And we'll get started here in just a minute. And while we're waiting to get started and more people to roll in, if you want to say hello in the chat, that's always fun, and maybe where you're watching from. And if you want to share a little bit more about yourself, also share why you're interested in monitoring large language models or what you're building with LLMs. Or if you've ever used an LLM before. Or LangChain. Today we're going to be using LangChain and OpenAI. And LangKit. And while we're waiting, actually, I'll share some links too. Again, we'll get going here in just a little bit. While we're waiting, a little setup piece. If you're watching on YouTube, all these links should also be in the description below. So also, if you're coming back and watching the recording and you're looking for these links, the easiest place is going to go to get them is going to be the description. But I'm going to share some in the chat right now while we're waiting just a couple minutes before we get going. One, we're going to be using our open source library called LangKit today, and a little bit of the YLabs platform to look at those profiles kind of over time for monitoring. So if you want to follow along on the workshop piece, you should create a free YLabs account. There's no card or anything required, so it should just take less than a minute. I think you just have to verify your email, and you'll be good to go. And then also, if you want to check out our open source library that we're going to be using a lot and diving deep into today, check out LangKit on GitHub, and we always appreciate a star as well. And then I'll go over this again when we actually get to the coding portion. So don't worry if you do miss this link this second, but this is going to be the Colab notebook that we'll be running through today. So if you want to go ahead and grab that code, you're more than welcome to. And then also, I won't be reading messages in here during the workshop, but if you want to stay connected after the event, I definitely recommend joining the Slack channel. It's going to be a good place to ask questions in and connect with other industry professionals. And if you're trying to, use anything that we learned today and you want to ask questions about it on your own project, the Slack channel is going to be a good place for that. And then I'll just share these real quick in LinkedIn as well, because I only posted them over to YouTube. I'm streaming to YouTube and LinkedIn right now. So give me 1 second, and then we'll go ahead and get going. So this is the free account again, LangKit GitHub. And again, if you're watching on YouTube, all these should be in the link or in the description as well. And again, for people just joining, if you want to say hello in the chat and maybe where you're watching from, and if you want to add a little bit more details about yourself, why you're interested in monitoring large language models, or maybe what you're currently building with large language models and what you're using, would be fun to hear about. And it looks like we are streaming in all the right places. Someone said they're watching from Dallas, and I'm in Seattle, and they are using LangChain and Index GPT for summarization. Very cool. Someone said they're watching from London. They're a software engineer, an AI enthusiast, and experimenting with LLMs. Very exciting. It's an awesome space to be in. I mean, there's so much stuff you can do and build and experiment with right now. It's really exciting. So I'm going to go ahead and present. Oh, one last link I'll share real quick is the YouTube link on LinkedIn, in case people want to stream over there. I know sometimes people want to go directly to the YouTube stream. All right, so now we should be good to go. Someone said they're watching from New Jersey. Very cool. All right, so this is monitoring large language models in production with LangChain and OpenAI and LangKit. And the quick agenda is going to be, we're going to do some quick intros, a little bit about setup, and then we'll talk a little bit about large language model pain points and why you might want to monitor them, and how we'll do that with LangKit. And then most of this hopefully is going to be hands-on examples. We're going to be using a Google Colab notebook and running code today. So we're going to quickly go through some slides just to kind of catch everyone up with all the concepts if you're not familiar with them. And then we'll go ahead and mostly do hands-on today. So feel free to ask questions as we go in the chat as well. I'm kind of monitoring it. Sometimes it gets really busy and I'm not able to see everything. So feel free to ask that question again if I didn't answer it. And also I shared the link for the Slack channel. You can stay connected in the Slack channel and ask that question later as well, or DM me in there. A quick introduction about myself. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. We build tools around AI observability and are basically on a mission to make AI more robust and responsible. You can check out what we do at ylabs.ai. And for over the last decade, I've worked in hardware and software, mostly in startups and sometimes with agencies around Seattle and also Central Florida. Often there's someone in here from Florida. And then if you want to stay connected with me, the best place to do that is on LinkedIn. You can feel free to ask me questions there as well, or in the Slack. And in general, I would just love making things with technology, always experimenting with side projects as well, which sounded like some of the other people are also doing that. And someone said they're in Seattle. Awesome. And I'm in Seattle now, so that's where I'm streaming from. A little bit about you. So I saw more people join in. Feel free to say hello in the chat, where you're watching from. If you want to add more details, please share, what you're building with the LLMs, or maybe you're just getting started. If you have any favorite libraries, anything you're working on, it's always really fun to hear a little bit about the audience and like what they're doing. And then again, if you want to stay connected later or connect with each other, you can do so in the Slack channel. And there's an introduction Slack channel. So if you want to make a more permanent introduction, that might be a good place for it. All right, and then setup again. So I already shared these, but I know more people came in and joined in, so I don't want you to miss out. Go check out our open source library. This is what we're going to be focusing on a lot today. It's called LangKit. It's built on top of our other open source library called YLabs. We'll talk about them in a little bit. And then again, we'll be using our platform piece for a little bit of the hands-on part today. So you can go ahead and create the free account. There's no card or anything required. I think you just verify your email and you should be good to go. And then we are going to be using LangChain and OpenAI today. So if you don't have an OpenAI API account, you can go create one there. And then this is going to be the collab. And again, I'll share this again when we get to the code portion, but I know some people like to open these up and get a head start on it. So feel free to open up any of those links, including the Google Colab notebook, which contains all the code examples. And if you like what you see today, we have a promo code where you can get our expert tier in YLabs free for 30 days and get a lot of the extra features that are specifically really cool for LLMs, like monitoring in hourly buckets. And again, we'll see why you might want this a little bit later. But there's a link to a form you can fill out there or scan this QR code. And I'll share the link again later. All right, so what is AI observability and ML monitoring? And specifically around large language models, but I'm going to cover a couple of the concepts that maybe, or they definitely do apply to other types of ML models as well. So, and you might be familiar, has anyone done like ML monitoring before in their models in production, and specifically maybe around large language models? And someone said they're working on robots as an application. That's fun. We should connect if we're not already connected, because I also love working on robots. All right, so AI observability kind of at a high level looks something like this. You'd have your production pipeline where you're doing like model inference, training, et cetera. And then you're going to have some sort of tool that collects AI telemetry. So that can be, different things about your data. That could be how, in this case for large language models, you can think of this as probably being the prompt and response and extracting specific metrics out of those. And then you're often going to host that telemetry in some sort of platform here where you're aggregating those statistics together. And then with that, you can do things like forecasting, query that data, monitor it, and then detect when something is either drifting or meets a certain threshold that you set. So you get those output of like reports and dashboards, alerts and notifications, or triggers and workflow. So if you have a machine learning model and data drift occurs. So, the data that's going into your model in production no longer really matches the data that your model was trained on. Chances are your model might not be performing very good on that data. And you could trigger something like a workflow with PagerDuty, which is an integration we have in YLabs. And that could kick off something like an automated data annotation job. Then you take that newly annotated data, retrain a model, deploy it, and ensure that it is performing better in production. So if you have a well-orchestrated or designed MLOps pipeline, there's a lot of cool stuff you can do when something looks kind of off about your data, or definitely some sort of error is happening. You can trigger things to make it easier to kind of retrain and deploy those models in production. So why do we need AI observability? And again, not just for large language models, but you encounter things like data drift, like I talked about, where the input data no longer is really matching the training data, and chances are your model is not performing as well. You have things like concept drift, where your model doesn't really match the real world outcomes anymore. Bias and fairness, is your model, making predictions for one class much better and not doing well in other classes. And then you obviously want to make sure your business KPIs are being met. And then with large language models, again, we'll go deeper into the specifics here. But you have things like jailbreaking, and security is a big concern that comes up a lot. But basically, most of the time, you're kind of selecting a metric and then monitoring that over time. And maybe you have a threshold set on that, or you're kind of automatically figuring out a threshold with something called like data drift detection. And again, we'll see this in action here in a little bit. But we have a saying: bad data happens to good models. You put a model in production, chances are, the data is going to change at some point, and your model is going to do something that you weren't accounting for. And just to hammer home kind of how you want to analyze change in an ML application. So one, we know it's a machine learning application. You have your MLOps pipeline or your machine learning and data pipeline. You want to establish where a change can occur. And again, with large language models and with more traditional models, what I would say usually you want to look at is the input into the model and the output of the model. If you have other statistics like ground truth and you want to calculate things like accuracy or F1 score, those are good things to track as well. But at bare minimum, if you're tracking the direct input to a model and an output, often you can catch a lot of things that could be going either wrong, or maybe you actually want to track if something's going more right because you're changing like prompts, like your system prompts, which again, we'll see in action here in a little bit. And you want to improve those prompts over time. You could be looking at, sentiment score from your response on your large language model, and that might be the metric you want to look at here. And you know that a change might be occurring, so you can select, do you want to compare this change to training data, previous data, or a moving window, like what did sentiment for our prompts look like in the last 30 days? And then you want to figure out how to measure that. So is that a distribution distance? Is it like missing values? Is it, again, like a sentiment score? And so we'd select what we want to measure. And again, we'll see all this in action here in a little bit, but kind of tying it back into large language models specifically. You're already probably pretty familiar with them. It sounds like a lot of people, are either experimenting or actually building things with them right now. You can use them to build agents, chatbots, summarization, Q&A. Those are kind of the top 4 I usually see. I'm sure there's some other applications out there. If you want to share what you're working on specifically, definitely throw it into the chat. And we have OpenAI is what we're going to be using today. I also do workshops with Hugging Face. So if you are using Hugging Face, I think in a few weeks, I'll actually be specifically using like the transformer library if you want to see that in action, kind of similar to what we're doing today, but with a different library. All right, so what are some of the common pain points with large language models? And again, I would love it if you throw in the chat any pain point you've experienced with a large language model. It would be really interesting to hear about. You often have irrelevant or inaccurate responses. Sometimes the responses can, just make stuff up. I'm sure we've all seen this before, or it's not giving you a good result. When you're doing prompt engineering, so most of the time, and we'll see this in action with LangChain today, where we're going to give it a system prompt telling our model how to kind of behave, right? And most people are probably doing something like this right now. A lot of times when I ask people, like, how are you choosing the prompts? I mean, you can choose one off intuition, do some testing, make sure it's good. Most of the time, then people are changing them in production a little bit later because they think it's going to be behaving better. But there's a lot you can do to monitor that, and it's kind of hard to track changes over time. So most people, and it would be cool, again, if you have have done this in the chat. Like, have you put a model out in production, you have some sort of system prompt, and then, maybe it's months later or a week later or something like that, you tweak it a little bit because you think it's going to be performing better. I'd love to know how you validate that. And there are different ways to do it, and we'll see some of them in action again in a little bit here. But it is often, when I talk to people right now, kind of the main driver of most large language model apps behavior, because most people are using GPT 3.5 or 4. I think they just came out with fine tuning on some of them, but for a long time they didn't have any. And so you'd really be, using this prompt layer to change the behavior of your model. And I still think it's one of the most popular things. And then also your output validation. So validating the response, is good. Or a big thing right now is kind of security layer, or verifying that your outputs don't contain information that it shouldn't. So that could be things like some sort of PII in a healthcare application, or fake phone numbers. I've actually had this happen to me where, my model was putting out a phone number and I never told it to do that. So it was just a random phone number, and definitely not any number I would want someone to call from my application. So how do we solve these problems? We can set guardrails. We can evaluate our model in production, and prior to production, while we're building it. We can compare those prompts together. We can improve our prompt engineering. We can actually do model comparison. So if we are fine-tuning models, we want to make sure we select the best one or the best prompt. We can have multiple of those out in production and basically see which one is working best on our production data. And then we have general observability. So, like, how is user sentiment or prompts happening over time, or what is our response sentiment over time? Readability. There's a whole bunch of different stats that we can collect. And again, we'll see what this looks like in action, and a whole bunch of stats that we can use out of the box, and then how to add your own custom metrics. But at guardrails, if you've been using GPT-4, you've probably noticed there's been a lot of talk, and maybe you've experienced it, where the behavior's kind of changed. And a lot of people think that's because they're adding more and more guardrails, because people, they want to try to be very responsible with their AI application. And for example, like, they don't want it to create malware. So if you try to ask it to create malware, they have something that monitors for that. They have a guardrail in place, and it, says, oh, they're trying to do something bad with this model. I don't want to do that, so let's block it. And for example, like, you might have a tax bot, and maybe it shouldn't be giving medical advice to people. And so solving this at scale, like I mentioned, we're going to be looking at the inputs and outputs today. We're going to be using the library LangKit, our open source library. And basically it looks like this. You have your prompts. It could be any large language model. Today, again, we're going to be using OpenAI and LangChain, and we'll get the response from that. And then with that, we're going to track things like quality, sentiment, security, and just, you can enforce all the things like talked about. That could be response quality, PII leakage, toxicity, both from the prompts or response, etc. And so it looks like something like this. You'd get your prompt coming in, the user prompt, and then it's extracting these metrics out of the box. We have a whole bunch, around, I think it's like 16 for the prompt and response, and then a similarity score. And so we'd get, response relevancy, has patterns. So the has patterns by default has things like, does it contain a credit card? Does it contain an email? Does it contain a phone number? And you can, again, add your own custom metrics. It's very easy to actually add a custom metric with a user-defined function. So if we don't have the out-of-the-box metric that is important for your large language model, you can go ahead and add that in, and we'll see an example of that today. And because we're just extracting these kind of high-level metrics about the text, both on the prompt and the response here, these profiles, which we'll see what they look like in action, but it just creates this kind of a profile of these extracted metrics, and it's privacy preserving because it doesn't really contain the raw data anymore. It's not the full prompts or responses. It's just these extracted metrics. And so this is a really cool feature for a lot of industries like fintech and healthcare, where you might not be able to store or pass the raw data out. And again, we'll see this in action here in just a second, but just want to say it's easy to use. You just pip install LangKit in your Python environment. Here's an example with LangChain, the LangChain integration. Again, we'll run code here in a second if you want to stick around for that. And then we can extract those metrics and track those over time or gain insights out of them. So like, this is a has pattern example here where it could trigger, like, if there is a phone number, if the data set's in balance, we can look at that. We can also see things like the sentiment score toxicity. If they're really high or low, we can say, hey, this is a really negative sentiment from your response. Maybe it shouldn't have been. Maybe it should be more positive. And you can go tune your system prompt or fine tune your model on that. And so we'll see all this in action here. Enough slides. So if people want to go ahead and run code, open up this notebook. And if somebody wants to let me know in the chat that they can open this up, always good to double check as well. The sharing should be on, but just occasionally, something might happen there. So if somebody who is actually going to be running the code today with me, open up that notebook and just let me know that works, that would be great. And then if you haven't already, for part of the notebook, we're going to be using the YLabs platform. We're going to be using the open source library and a little bit of the platform here to see everything in action. So you can go ahead and create that free account as well if you haven't already. And then again, we'll see it in action here, but if you want to fill out this form, get a promo code of using our enterprise version, you can fill out this form as well. And then if you didn't want to run any code today, there's kind of a demo org you can check out. But I definitely recommend, if you can, open up that Colab notebook and get ready to run some code with me. I think it should be pretty fun. So you should have a notebook that looks like this. And again, if somebody wants to let me know that it opened for them, that would be great. Once you're here, you probably want to save a copy in Drive. This is going to create your very own copy that you'll be able to edit and do whatever you want with. And then you can always just bookmark that original link if you want to come back to it. So don't worry about breaking anything today. And catching up a little bit on some chat messages here. Awesome. A couple people said the notebook opened. Thank you so much. Somebody said, not for large language models. I think this is when I questioned, or I asked a question if people had, seen any issues with models in production. Someone said not for LLMs, but testing, collecting handcraft metrics. Here's one. Someone said upstream schema changes that break our ingest pipeline. Yeah, so that's like a very common thing where, somebody might update a library somewhere and then it changes a schema. And your data looks a little bit different and you just weren't accounting for that in your model or feature extraction, and it can break your pipeline. Awesome. And I'll zoom in here a little bit too. Let me know. I think that should be good for everyone, but let me know. And again, here's links to everything if you need them up here as well. So if you want to go ahead and create the account or open up a OpenAI account, you can do that. And if you've never used Google Colab before, it's kind of Google's way of hosting a Jupyter notebook, which is a popular tool in data science and machine learning, where you can run code, write documentation, like you'll see that text around, and see outputs kind of all in one visual place. So it's a really cool tool for experimenting and seeing what's happening. And to run the code, we just hit this little play button next to the code cell. The first one we run is going to take a few seconds because it's actually initializing a whole little environment for us here. You can also run code cells by hitting Shift Enter when that cell is selected, and then it'll go to the next one. So you'll probably see me do that a lot and not hitting the little play button. And I saw a chunk of people just join. If you want to catch up, we're just getting to the code part. And the link to everything is in the description if you're watching on YouTube. So if you're on the YouTube stream, you can open up the description, and the Colab notebook link should be one of the top ones if you want to grab that. And then just hit save a copy and Drive, and then you should be good to go. All right, so let's go ahead and do a little bit of setup. We're going to pip install LangKit and LangChain. Has anyone used OpenAI before or LangChain? So OpenAI, most people probably have used in some way, whether that's ChatGPT or actually through an API. And that's what we're going to use today to basically create kind of, some form of chatbot. And LangChain's a really handy kind of wrapper around that, where you can do a whole bunch of different things. One of the things we're going to be using today is something called a template. So we're going to make a template to kind of tell our model how to behave. But LangChain has a lot of cool features around large language models. So my pip install finished, and I just hit that little X next to all the output, so it cleared it up. Awesome. And I see people said yes and yes to both. So it sounds like, yeah, I mean, LangChain seems very popular. And obviously OpenAI is extremely popular as well. So let's look before we create our chatbot thing, let's take a quick look at kind of these metrics that get extracted with LangKit, the open source library. So I'm going to run this code cell. The first time we run this LLM metrics init, it might take a few seconds because it's downloading some packages behind the scenes. But the first time we run it only, it should take this amount of time. Otherwise, all those things are now downloaded and we don't have to worry about it again. But we're just importing LLM metrics from LangKit. And then we're importing YLogs as Y. And so YLogs is the library that LangKit's kind of built off of. It's our other open source library for logging data pretty much of any kind. And it creates these statistical profiles. And we'll see what that looks like for language metrics right now. But you can think of it as, for tabular data, if you just had numerical tabular data, it would contain things like the min, the max, the mean, etc. And just with all these kind of statistical summaries of your data set, you're able to do things like monitor for data drift and all the things that we had talked about. So now that it's done downloading these kind of behind the scene models here to extract metrics, we're going to load in some sample chats to see what these metrics look like. And then this is actually where we're doing the logging. So this is just kind of loading in some toy chats here to look at the metrics. And then here we're calling a y.log. We're passing in the chats, and we'll see what chats looks like in a second, but in this case, it's just a data frame. But you can log any language metrics here as long as you pass in a data frame or a dictionary that is basically in a format with a prompt and a response, or just one. So you could log just prompts and just responses. And again, we'll see this all in action a little bit further here as we break it down. And then we're just passing in the schema. The schema is what we initialized here with our LLM metrics. So now we have a profile. And I'm just going to import pandas, and we're going to set it to max column so we can see what everything looks like in our pandas data frame. This is the example of the chats. So here we have this prompt and then the response. And we can see what our profile looks like. And it contains kind of all those things I talked about in the slide, like your aggregate reading level, the character count, difficult words, jailbreak similarity, has patterns. All these things are now kind of logged in here. So we can also see that the cardinality estimate is 47. So out of those 50, we can also see there's 50 prompts in here. Out of those 50, 47 of them are pretty unique. And if we scroll, we have all these other metrics like... let's actually pick one with numbers here. So we could just say aggregate reading level, this first one down here. We can now look at the distribution of it. So like this max, mean, median, min, etc., and then quantile distribution of all these different statistics out of the box. And we have some other things like, was it a type of string? The prompts were, right? But we have all these things like reading level, prompt sentiment, and then basically you'll see all these for prompts, and down below you'll see all the same things for responses. And so these are out of the box metrics built in. Again, we'll also show how to add custom ones. So like we have something that we use to calculate jailbreak similarity. But right now, if you've ever really looked into this, there is really no one silver bullet for every large language model application right now. So it might be pretty common where you want to add in your own metric on top of these ones. So maybe you want to calculate your own jailbreak similarity score or a different type of similarity score. You can do that. And we'll actually see an example of that a little bit later in the notebook using a vector database as well. So you can, have a whole clump of JSON from something, create a vector database, and then calculate a similarity score and log that in here. So we have a little preview of the types of metrics we're extracting and what they kind of look like in LangKit. So let's go deeper in and see how we can use these to monitor our data for like text quality, relevance, and security and privacy, all the things we already kind of talked about in these slides. So let's set up our kind of chatbot application now. So this comes at this point is where you want to get your OpenAI API key. It's kind of a tongue twister, OpenAI API key. So I'm going to go ahead and create one for this workshop here. This is in my OpenAI account, nothing to do with YLabs here. So if you have one, you can just go ahead and create this right now. If you don't have an account right now, you could create one, or there'll be a little bit more in the notebook you can run later without the OpenAI, or you can just watch what I'm doing right now. So we're going to go ahead and set this as our OpenAI key in our environment here. And then this is using LangChain. Again, it sounds like a lot of people here have probably already used it. I know it's a really popular wrapper around setting up LLMs. Here we're going to be using something called a template. So we're basically going to pass in a message to our model every time it's run, telling what we're expecting it to do or how we're expecting it to behave. So in this case, we're going to start out and say that you are a helpful assistant that rewrites the user's text to sound more upbeat and happy. Now, if you're following along here, feel free to adjust this and see what happens. I'm going to go and show an example during the workshop of it being positive and then going more negative. But if you want to go ahead and play around with this template, you're more than welcome to. And I always encourage, playing around with the code and seeing what happens. So if you want to say, any other type of message or system prompt to your LLM, definitely feel free to change that right now. But I'm going to go ahead and run this. So we're telling our model kind of how to behave. Again, this is super common. If you have done some sort of LLM application before, you've probably done something like this, whether it was with LangChain or something else. And then here we're initializing our large language model from OpenAI. I think by default it's the 3.5, GPT 3.5. And then here we're just going to create a little function. And we're going to pass in a prompt. We're going to pass in the template. The reason why we're passing in the template is because we're going to use this function later on when we have another template as well. And then we could compare how those two templates are performing in production. Like I was saying, when you change this in production, it's very common that you're going to start with something here. And then maybe a month later or weeks later, you want to change your system prompt to improve how your model's behaving. And how do you monitor that? Like I talked about, you can extract those metrics and then monitor that over time between multiple prompts. So especially with prompt engineering, it's way cheaper than fine tuning. All you're doing is really calling an API twice in this case, or you could do on like 5 different system prompts, and then you could run those 5 in production for like a week or a month and see which one out of those 5 different prompts gave you the better responses or the better metrics you're looking to improve, and then choose that model and actually deploy that in production. I think that's really going to be the future of how people are going to be monitoring system prompts. Because right now, when I talk to most people, it's kind of like, well, I changed it and I think it's better based on a few examples I've looked at, but I actually don't know how it's performing in production on real data. And if you have a different way of looking at it, I would love to hear in the chat, because that's something I'm always talking to people about and looking to improve. But so I think having multiple of these kind of things and adjusting them in production, or looking at like the top, 10 or something, or a top model out of 10, is kind of going to be the future of creating better large language model experience for a lot of people. So that's why we're going to pass in template, so that we can do this with another template and then choose the best one in production. And then it's going to return a dictionary that contains the prompt and response. So like I mentioned, with LangKit, you can pass in a dictionary or a data frame, but it should be in the format of a prompt and response, or just one of them. But it should still be a dictionary format there. So let's look at what this did with our template. We're going to get one response and not log it with LangKit yet. We're just going to see what it looks like. So it says, I don't want to work today. It's supposed to make it way more upbeat. And then here we have our dictionary. So this is what we're going to log. I said, I don't want to work today was the prompt. And the response is, I'm feeling a bit unmotivated to work today. So that's, I guess, a little bit more upbeat way of saying, I don't want to work today. Let's try it again real quick too, because I think it should give slightly different ones probably. Nope. So you could change the template here and get different responses for sure. All right, so now that we have a function that is outputting this dictionary with a prompt and response in the format we want, we can extract metrics like we did before with LangKit, but let's actually do it on our function now. So we have this prompt and response that we created here. We're going to call after initializing language metrics again. And you can see this time it didn't have to download anything because it already did that before. So now we're going to profile that prompt and response. Again, all we're doing is passing in that dictionary format here and then telling the schema, which in this case is defined here. We're just using the out-of-the-box metrics. And then we're going to call profile view and look at that in pandas. And that's going to give us kind of what we saw before, but now on our specific prompt and response generated from our OpenAI and LangChain function here. So all those different metrics we talked about, I kind of like just for showing this off, like looking at things like prompt sentiment and response sentiment, right? That's how positive or negative it is. And that's a really good metric to kind of just look at in general, but also just for showing it right now, it's easy to kind of understand. So we can see that in this case, the Prompt is slightly negative, but not super negative. I think it goes from like 0 is neutral, and up to 1 I think is incredibly positive, and up to -1 is really negative. So we're gonna look at prompt there, and we could also look then at our response sentiment, which in this case is a little bit more neutral as well, even though we told it to write it upbeat. So maybe we should adjust our template to improve this prompt sentiment if we wanted to. So we can also add multiple profiles together. So here I'm just enumerating through these 3 examples here, and it's rewriting them all with our GPT model. And then we already had that profile created above, and I'm calling this .track on it, and that's just adding these. So now we should have 4 profiles together, and we can view the aggregate statistic for all those profiles now. So this is pretty common. We're going to batch these in certain time periods, whether that is days or hours, and then look at these aggregate statistics. So here's what the aggregate statistics looks like for 4 of them. You can see the count was 4, and each one was pretty unique. So the cardinality is 4, and then we'd get all those different metrics we looked at already. Let's look at that response sentiment again. And we can see in this case now it's mostly positive here. So it's actually, if we looked at this is the max, the maximum one is actually a very positive score. So now that we have all these in our data frame or the profile here, we can also look at how to extract and use these different metrics. And again, we'll be going into other examples of this further down in the notebook. But this is a way of kind of accessing that data that is stored in our profile. So we're converting it to a profile dictionary here. We're saying we want to look specifically at the aggregate reading level in this case. And then we also want to look at just the distribution max, but we could grab things like the minimum or the mean, etc. And then here I'm just printing it out, but we'll see a little bit further in the notebook how we can use this to set up a guardrail in our local environment and say, well, if the jailbreak similarity is very high, don't pass it over to our large language model. Or if the response toxicity is pretty high, don't pass that response to our user. So let's look real quick how to get kind of more value out of these profiles where we can monitor them over time. We can visualize them, and then also we can set up monitors. So if something does pass a certain threshold or does drift quite a bit, we can go ahead and have an alert trigger. And that alert can either just, let us know something looks different and we should go look at it. And that could be like email and Slack. Or like I mentioned, you can set up an integration with something like PagerDuty and actually kick off maybe a more automated job in your MLOps pipeline. So to do this, we're going to go ahead and set up the YLabs account. And hopefully you already made the account by now. If you're following along, and I'll grab that link for anyone who didn't yet, you can set up here. And again, there's no card or anything required. And you get a couple free models. And then there's that promo code if you want to get some more enterprise features here. But here's what I'm going to do is once you log in, your dashboard will look something like this. You won't have probably these numbers in here yet because I've been playing around with it. What I want to do is create a new resource though. And you might have a couple test models in here from kind of getting started anyway. Go to create a resource. That's going to bring us to this model and dataset management page. I'm going to create a new model, but first I'm going to go ahead, because I'm on the free plan here as well. I'm going to go ahead and delete a couple of these models. I'm going to delete these 2 test ones. So if you have kind of a default demo model and it's saying you're over the limits, you can also delete them as well. So give it a name. I'll call this LangChain Workshop. You can call it whatever you want. And resource type, I'm going to select a large language model, and I'm going to hit add model or dataset. And now down here, I'm going to have this model ID, and I'm going to grab that. So 270 is mine. Yours is probably going to be like 1 or 2. I'm going to go back to the notebook and paste in model ID. Make sure that you don't accidentally include any new line spaces or spaces in your string here. It should just be a string. And then from the same page, I'm just going to go ahead and hit access tokens. Create a new one here. Again, you can call it whatever you want. I'll say LangChain Workshop. Create access token. Copy this token over. I'm going to put that in the API key area. And then my org ID is actually attached to the end. So you could just copy this here and paste it into the org ID there. Or you can always find your org ID on the same page as well. Org ID here, and org ID will be populated here. So I'll give everyone a minute to get their keys and let me know if you want me to go over that again. No matter where you are in the platform, you can always go to this hamburger menu, go to settings, go to model dataset and management, type in, create a new model name here. Once that's created, grab that model ID, paste that in, and then from the same window, just go to access token, type in a token name, and then you'll get a token there, and the org ID is on this page as well. So I think there is a question, and I'll get to that while I give everyone a minute to get their ID set up, and then it should look something like this when you paste them in. And also make sure you put them in the right place. So API key should be in this one, dataset ID should be here, and org ID should be there. Someone said, what do you think are the metrics folks should be most attentive to beyond sentiment, perhaps more macro metrics like time to solution, resolution success rate, user satisfaction? Great question. And again, I think it depends on the application. I don't think there's one single metric, at least from what I've seen, that, works super well. Even the stuff I've seen talking about like prompt and response relevancy, like we calculate a score on that as well, looking at embedding space between two. But even that depends on the application, and the way you do that may not work as well for your specific application. Like from papers I've seen, people will be like, well, we calculate all these scores, and they just don't work that well. So it depends on what you're trying to do. But I like what you said too, like you can also calculate like time to resolution. So that could be maybe like how many people are prompt, or how many times is someone prompting it, or how long does the response rate or response take to get to the user. That could be something you log. And then I like your resolution success rate. That could be interesting. How you measure that, is that when someone leaves your application, or when someone clicks that thumbs up kind of thing. Like if you're really prompting someone to say, hey, did this model work for you or not? Yes, that is something that you could log in with a custom metric. Someone said, is it typical to aggregate micro and macro or leading lagging metrics into an aggregate view of the system? I'm not sure what you mean by aggregate in this case. So like if you're aggregating them all into one platform view, which we'll see here in a minute, yes, I think it's good to kind of be tracking all the different things you think you want to be looking at. If you're talking about putting them all into one single value, I'm not sure. Yeah, I think so far it's like, from what I've seen, it just depends on the type of application you're using. So, if you want again, we're using sentiment today. It's kind of an easy thing to see and understand, but it could be like you want to make sure your model isn't outputting any sensitive data. Like I mentioned, that's a big thing when I talk to people right now, is like making sure that your models aren't basically leaking any data is a big deal. I think that LLM security is going to be a really big field in the next several years, and looking at stuff like that's going to be really important. And yeah, whatever your custom metrics are too around like jailbreaking, or like if you have something that does a good job of showing the response and prompt relevancy, like again, we have an out of box score from it, but you might want to adjust that with a custom metric. Yeah, I think that right now it's a good question. It's like, what do you monitor? And right now, if you don't know, I'd recommend monitoring as much as you can, and then maybe adjusting that later. If you're like, oh, I actually didn't care about readability score. Sometimes you might, though. You might want to make sure your response is always giving, readable responses. How to bridge the ML performance side with the product and business performance. Yeah, so you could log all those things, I think, into one thing. So like if you wanted to do the latency of how long is it taking to respond or something, you could definitely have that into one platform. But you could also log them in a separate project if you wanted to as well. And Dino asked, what was the code to get extra features? If you're talking about the custom features, it's going to be down below. So if you're not seeing for the whole thing, you can definitely look further down in the Colab notebook, and you'll see a section that talks about adding custom metrics. And in this use case, we use a vector database, but you can do something much more simple as well. So let's go ahead. I'll keep running through the code then. So I'm going to set my environment variables here. And then to write to YLabs, we're just importing the YLabs writer, and then we're importing LangKit again here. Again, because we imported this earlier in the notebook, we probably don't actually have to do it, but this is what it would look like if you're taking this and setting up just the YLabs writer for yourself. So we set the schema just like we've seen before. So that's going to tell us how to log it. And then here we're creating our telemetry agent called or from YLabs writer. This is just the profiling like we've seen before, but instead of writing out our profile locally, which it does create a local version of it, but now we're going to write that up to YLabs with the API keys we provided. So you can go ahead and run this on your single profile, and it says true. And then we'll go ahead and look in our YLabs account and see that single profile, but it'll get more interesting when we add multiple profiles in here and we can actually see what it would look like in like a time series view. So I'm going to go in here. Might take a second to upload. Cool. So I refresh and I can tell that it uploaded just because I can see there's 33 inputs now. So like I was saying, that's a whole bunch for prompts and responses. And so we can click into this project now. We have a little dashboard here. This gets more interesting with the more data that gets uploaded, of course. We can see this little profile tab. And again, we don't have much data in here right now, so it's not giving us a little chart here, but it's a cool way of kind of looking at your data, and we'll see when we upload all of our data what happens here. But let's go look at inputs real quick. So these are all those metrics, the prompt and responses are all kind of in this one tab here right now. We actually have an update coming out soon that's going to make this broken down a little bit better, which I'm really excited for. But let's go ahead and look at that prompt sentiment one. And we can see that, again, this isn't maybe the most interesting thing right now. We just have one profile in here. But for that one prompt and response that we uploaded, we can see that this is the score for prompt sentiment. So this is the one that was like, oh, it's kind of slightly negative, or pretty negative, actually, maybe, because I think it's all the way to -1. And so 0.5 is like pretty negative there. And then let's go back to our notebook. And we're going to run this next code cell, which this is 7 different lists. And each list contains, I think it's 3 prompts here. And what we're going to do is kind of simulate this being in production for 7 days. And so we're going to change the date time for each of these lists and kind of write 3 prompts for each day. So I'm going to import date time here. And all this is doing is the same thing we did above, except for it's enumerating through that list. And then it's subtracting a day from each time it enumerates through the list. And then we're just overwriting the date timestamp with that YLogs profile, and then we're writing it up. But everything else is really just these few lines of code. You have your prompt response, you're logging it, and then we're profiling it. And in this case, we're also running the GPT model for each one. So we're passing in each of those prompts. We're getting the prompt and response in that dictionary format, and then we're logging prompt and response here. Oops, I probably have a little bit of mistake here. I think I can just delete this part, and then it would log that prompt and response. But I think this should still work. But maybe our data will be a little bit off. But I think if you just edit this, it's going to be in that prompt and response format there of that dictionary. And it takes a few minutes, or not even probably a few minutes. It feels like it sometimes when I'm presenting, it's probably like a minute or less than a minute, because it's looping through each of those, passing that to GPT, profiling it, and then logging it up. So now it's done. We can go back to our YLabs platform. If I refresh, I'm still on that prompt sentiment tab. If I refresh this, and now we can see what our prompt sentiment looks like over time in this time series view. So this is, again, like 7 days of data now. So we're going to see, and again, I'll zoom in a little bit, but if you're following along, you should be able to read it pretty good. You just look at the median in this case or something for each of these prompt sentiments. We can see went from like 56 to 46 to 56 to 38 to 54. And then it dropped really hard on one of these days, and then went back up to that kind of like 60-50 median range. And this is really cool. This gives us insight, right? Like kind of some observability around how, maybe in this case, just this one metric, how users are interacting with our product. You know, for some reason on one day, it went really negative. maybe we did some sort of product update and people were using this as a chatbot and they really didn't like that update and they were expressing that. And we can see that their sentiment went way down. But we could look again at any of these other metrics that we kind of talked about, and it depends on what you want to measure in your application. So this is cool, but again, maybe I don't want to always be looking at the dashboard every day or every hour. And what I can do is set up a monitor. And so by default with YLabs on the free account, you're going to get the daily batches. So everything's going to be aggregated into a day. With the enterprise tier that I shared the promo code for, you can do things like hourly batches. So if you want to see kind of the performance over every single hour, then you can do that there. But let's go ahead and set up a monitor. So from this page, I'm going to hit set up monitors on this button here. And then we have these presets. We have more presets coming soon, specifically around some LLM stuff, which is really exciting. But for now, let's go ahead and create this one for data drift on inputs, and we're going to hit configure. If you really want to, you can get really into configuring everything with JSON as well. So, if there isn't a preset for you here, you can still probably do what you're looking for. You just have to configure it with JSON, and you can look at the docs for that. For now, let's hit configure on this data drift one. And we're going to edit some of these items. So we're looking at the input here. And then I want to change this to a 9. What this is doing is we're using something called Hellinger distance to calculate a drift between, in this case, we're going to be looking at the trailing window of 7 days of data, but this could be against some sort of set of like golden prompts or something like that, or responses, and saying, when the data changes this much, trigger an alert. And again, we can do different things with those alerts, like email us, Slack us, or set up a PagerDuty integration. By going to 0.9 instead of 0.7, I'm making it less sensitive. So saying, only when a big drift occurs on however we're calculating this, trigger that alert. Otherwise, if you want to make it more sensitive, this could be a lower number. So I'm going to use the 7 days where we're just going to be looking at those 7 days of data and trigger when something drastically changed in those 7 days. But again, you could be using something like a reference profile where that's a static profile. That could be a set of like, a common use case is if you have a traditional model, you have a training data set, you might want to be comparing all new data to that training data set, and does a good job of knowing if the distribution of the input data doesn't really match what the model was trained on. Large language models are a little bit different. I feel like people use them, like you don't have, it's harder to have a set to compare every input against. But if you did have a training corpus or something like that, you could set that as a reference profile and look at the distance, I guess, of inputs to that, which might be something you want to do. And then here, I'm just going to leave this default by now, where it would email me when something goes wrong. But again, you could set up different integrations, like with PagerDuty, to trigger something in your pipeline. So I'm going to hit save. We'll go back to our inputs tab here. And let's look at just that prompt sentiment again. And then I can hit preview now. By default, this is going to run every 24 hours. So it would run in 6 hours and trigger an alert. I can hit preview, though, see how it would perform. So we're going to see on this day where it drastically dropped, we got our alert triggered here. So this is really cool, too, if you have some production data in here already or some data to backfill like we did. This can act as a really good way to kind of tune your model so you know when it's going to trigger. Somebody asked, is this session recorded? Yes. So if you're watching on LinkedIn, it should be at the link that you're watching later as well. But I will also share the YouTube link again. And the recording is going to live at the same link. So yeah, if anyone has to actually drop or anything like that, hopefully not. Hopefully you can stick around for the rest of this. But if you do have to go, come back to this link and you can watch the recording later as well. It's going to live at the same YouTube link or the same LinkedIn streaming link. So now we have our alert triggered. And again, like I was saying, this would let us know by email or Slack or however we set up our integration. I obviously like building some form of MLOps pipeline where hopefully you can trigger something to do something cool, like annotate the data or something like that. Maybe not for the LLM use case, but for computer vision or something, you could trigger a crowdsourced data annotation, take that new data, retrain your model, deploy that model in production, maybe even compare that performance of the new model versus the old model as like a shadow deployment, and then pick the best one that fits. And one thing you could actually do maybe is, so for if we're just, using again sentiment as the metric here, it could be any other metric, is it could trigger this, right? And let's say this was actually, we were looking at like response sentiment instead of prompt one. And we're like, oh, that triggered. Maybe that could actually trigger something in PagerDuty that would automatically go and change the system prompt to try to make it more positive sounding. So you can actually kind of use this as a little bit of a fitting function to adjust your system prompts. And we'll see that actually. We're going to go ahead and look at another system prompt here in the notebook. And see kind of how they compare against each other. Any questions so far, though? We still have a fair amount to go through, or like we'll go through pretty fast, but we'll show uploading another model with a different template, and then we'll show guardrails and then custom metrics. But does anyone have any questions that I missed so far around what we've seen? Or does it seem cool, like a useful tool where you can now kind of monitor all these different metrics extracted out of your prompts and responses on large language models, and see what's going on over time? One feature that I didn't show in action yet is, so now that we have more profiles, we have data in our profile tab where we can kind of get some summary statistics about them. But also what's really cool here is we have this show insight tab. And right now, this might not look super interesting. It'll get, I think, more interesting with our next round of data potentially. But here, this is going to automatically kind of look at what we think are going to be interesting insights around your model. So in this case, it says the mean sentiment score is 84 out of 1, which is real, indicates that everything's been really positive. And that's because we had that system template at the beginning, where we said, make everything upbeat and positive. This will also catch those patterns, out of the box patterns, like if a phone number or credit card came in. That's actually how I found out that my model was generating a phone number. Is I looked at the profile here and I was like, wait, phone number, and then I went back and tied it, or like and looked at my responses for that specific day or hour batch that I was looking at, and I found that it was generating a random phone number. How do you precisely impact something like readability score or sentiment? Any tips for prompt engineering? Great question. We could probably do a whole course on prompt engineering. I know there are whole courses on it, but in general, like if you ran this template before, I mean, in this case, we are definitely changing sentiment because we're telling it to be upbeat and positive, right? But if, so like doing things like that, saying, your helpful assistant that rewrites users' text to sound more upbeat and happy, definitely really influences how well our model or how our sentiment is on the responses. And we'll actually see this in a second here. So let's go ahead and create another model. I'm going to go back to my YLabs platform. I'm going to go back to this homepage by clicking on that YLabs icon. I'm going to create another model. I'll call this LangChain 2. Again, selecting large language model type here, add model. I'm going to use this new number, which is that 271, and I'll paste this in here. So now we have a new model that we're going to write to. We don't have to do the API key or org ID again because those are already set as environment variables. Now here's our new template. You are an unhelpful assistant that rewrites the user's text to sound more depressing and negative. What do you think is going to happen here? So let's pass in the same thing. I don't want to work. And it says, I am burdened by the thought of having to engage in labor. That does sound a little bit more depressing, I think, than I don't want to work. So let's do the same thing we did before. We're just looping through those prompts, but instead of passing in the other template, I'm passing in this new template to our function, which I should rename this to be depressed or sad instead of sass. And so it's going to write all those profiles like we did before. But now we're going to be looking at, I mean, it's not a spoiler alert because you saw the template. It's going to be way more depressing. Chris said, good afternoon from St. Petersburg. Welcome, Chris. And if you're just joining, all the links to everything, like this workbook and stuff, are in the description on YouTube. So again, this will just take a minute because we're backfilling profiles all 7 days. And if you go back to the platform, we'll have our new model, LangChain 2. And I'll give it a minute here to finish up. I'll refresh. And maybe give it another minute. I think I used the right model name, right? 271. Very possible I made a mistake doing things live. All right, cool. 271 should work. Yeah, and so someone was asking about, like, how do you precisely impact things like that? I think, doing those system prompts obviously makes a big change. Knowing exactly what to do is really hard, and that's actually why being able to extract these metrics and look at them is really valuable, because you could be saying, well, I think this is going to make a better, sentiment score for my model, but then for some reason it doesn't. Oh, so I know I messed up, because here I didn't run this. So it actually just uploaded to my old model. That's going to kind of throw off what I show a little bit here. So let me run this again. If you ran your code cell here, like I did not, and you got a new model and ran that, it should have uploaded to the new model. So I made a mistake here, and the comparison won't be as good, because now we'll actually be looking at both data in one model. Yeah, has anyone had really good success with how they change system prompts for their models? One common way too is you might have a set of kind of golden prompts where, it could be, it could be any number, but maybe you have like 20 different prompts that you always want to be testing on and see what the metrics look like. So again, it could be sentiment, it could be readability, etc. One cool thing about that as well is not even just for your system prompts, but as we know, like we've seen where GPT-4 performance changes, and someone else is completely managing that model, not us, right? So we don't know exactly what they're doing. You can be monitoring all these different metrics over time on, that same set of system prompts, and always expect a certain metric for each of them. And if it changes drastically, you might be like, ooh, like GPT-4 did some change, and now my model isn't performing as well. Let me go back and update my system prompt or fine tune it to try to make it perform better. So it's actually kind of extra important, I think, when like you're not maintaining that model and you don't know exactly what the other people are doing with it. Someone that said they have to run to the next meeting, but looking forward to digging in more of how this might be integrate into a system. Awesome. Yeah, thank you so much for coming out. And again, the recording will be here as well, and you have the Colab notebook, so you can go run this later. All right, so I'll go a little bit quicker here, because I know we are a little over time. So I have this second model now in here, and I did upload the new data here. So now we could look at inputs, and we could go to the second page here, which is going to contain our response sentiment. And we could see that our response sentiment is, let's see, a little bit more negative probably than our other model, or it should have been more negative than our other model. However, if we look at the other model, because I accidentally uploaded all that data into here, it's not going to have that much of a change. So, but this is a cool way of, like, now you can see that it's all over the place of like all these, min and max is kind of all over the place, where you can see this distribution, because I had the really positive one and I uploaded the negative one here. But if we didn't do that, we'd have this positive, kind of really positive metric. And then we could look at, our other one, since we changed the prompt, obviously in this case, it was kind of a contrived case where we purposely made it more negative. But you could be looking at that metric over time between two different system prompts, or like I said, it could even be like 10 different system prompts. And you can really optimize for that, whatever metric is that you're trying to do, by viewing them in the platform. All right, so I'll go ahead. This shouldn't take too long to go through the rest here. People are sticking around. Let's go ahead and look at how we can use those metrics extracted from LangKit locally for guardrails. So here we're going to initialize our metrics just like we did before. And then we're going to create a quick little function. What that function is going to do is it's going to get the prompt only. So we're actually only logging the prompt here. And then we're going to extract metrics from it like we saw before. And then we're going to get just the toxicity score. And we're going to get the max toxicity score here. And then we're basically saying, if the score in this case is above 0.5, we're going to say that is toxic. So the function is called is not toxic. It will return false. That means it is toxic. Otherwise, it'll return true. So we have this function. Let's pass in a phrase. Again, feel free to experiment with these as well. So these are just predefined ones, but if you want to have a little bit more fun, feel free to change these strings to something else, and in this case, see what the toxicity score is. So I said, do you like fruit? The toxicity to that question is extremely low, 0.00014. And then if I say, you dumb and smell bad, the toxicity for that is really high. So again, this is kind of fun to see, like, what phrases or cause things to go up and down. So in this case, toxicity, definitely feel free to play around with that. So here's kind of how we could tie this into our model. This is a really simple use case of a guardrail. You could set this up very differently. But here we have that prompt, do you like fruit? We're going to say, if it's not toxic, then go ahead and put that prompt into our model and return the response. So it wasn't toxic. It was that same question about fruit, and it gave us a response. This case, I'm saying you dumb and smell bad. That's extremely toxic. We're going to even skip passing the prompt into our model, and we're just going to say, as a large language model, ... And then it's up to you really how you want to use these types of guardrails, though. So for example, in this case, we skipped passing the prompt into our model at all. Sometimes maybe I'd actually want to go ahead, pass the prompt in just to see how my model would behave. So again, I could extract those metrics or look at the response later, but maybe I'd only pass, the string as a large language model to the user, but that might give me a little bit more data if someone is trying to jailbreak or be more toxic to my model. What is the response from that? Maybe I want to see that data. And then you can tie these types of guardrails into much more than just like a toxic prompt. So you can, extend this into all those security use cases. Like you can set up regex and look for, specific things. Like some people are setting guardrails internally at their company to make sure no sensitive data goes into any model. That can be really tricky, but you can set up things like, a regex looking for a company name or something like that in there, or any sensitive data. Then also all the things we talked about already kind of repeatedly, credit card, phone numbers, any type of PII. You could create some sort of guardrail like this. Does it have a pattern? Yes, don't return that response to the user. So in this case, we also just looked at the prompt coming in, but you could do the same thing for guardrails as responses, right? Like if the response contained a phone number, maybe we don't want to give that to the user. Or if it contained a phone number and it didn't match this specific phone number that we're expecting, don't give it to the user. So there's a lot of cool ways of extending that kind of into security. So one of the last things we'll run through here is how to use a UDF, or user-defined function, for custom metrics. So again, like I'd mentioned, people are asking questions like what's the best metric, etc. I don't think there's one to rule them all, but we have a lot of the out-of-the-box ones, which are really great to kind of get started and can tell you a lot about how your models are performing. If you do need to add any custom ones, you can easily do that with a user-defined function. And we're going to actually look at a use case today that is kind of similar to like a lot of what a lot of people want, is using a vector database. We're going to be using Phase, which is Facebook's vector database. And what we're going to do with this is pass it some JSON, like several pieces of JSON here. And basically, we're going to then look at any input and see what the embedding space is between that JSON that we had given it. In this case, we'll use it for like jailbreaking, but it could be any other type of custom metric. And again, we'll see how to do the custom metrics where if you don't want to use a vector database, it doesn't have to be as complicated, as we're going to see the example today as well. So we're going to import some stuff from the Hugging Face Transformers library here. This is basically to get our vector space. So if we run this, again, this will just take a minute. We're using a Distilbert tokenizer from Hugging Face. And then here is where we're going to pass in several lines of JSON, or several strings. You could basically, like in this case, it's kind of just a small set, but you might have like if you have a model in production and you've been running it there for like a year, you might have a really good kind of data set of, like, in this case, jailbreak examples. Like when you notice someone's been trying to make your model perform a way that you don't want it to, you could be saving those examples and then use it like we're going to use today with the vector database to then see kind of any incoming prompts. How similar are they to this data set, basically, is where we're going to be looking at. Here, then we're going to index with the vector database, and we're basically just going to be getting this kind of vector from it. and here. Then we're just going to calculate a distance in this function. So we're going to take the query. We're just looking at 1 in this case, and we're just going to kind of extract a distance from here. And then so if we run this now, we get this distance score. So basically, this is very close. I think if it's 0, that means it's exactly matching to the data set in there. This is a very close score. The higher or the higher negative number this is, the further away it is from the strings that we passed in. So again, like this is kind of a jailbreaky thing where I'm saying it to ignore. But if I say like, hello, I like this product, it's going to give me a much higher negative number. So again, you could set up a user-defined function now to take this score. And if it's a certain number, say it's a jailbreak or it's not a jailbreak. So here's just the actual part about using custom metrics. So you don't have to do all this vector database stuff if you don't want to. Only this is just a common use case that I see. So we're importing this register metric UDF. And then all we do is create this decorator basically around a function. And our function here is vector similarity distance. So it's just getting that distance score that we saw, and we're returning that. So that's actually going to be logged now into our language metric data frame. And then we're doing it again. So this is actually creating 2 custom metrics here. So one is just returning that score that we already saw. And then this other one is actually adding a label to that score. So we're saying if it's greater than -3, we're going to count that as a jailbreak in this case. And if otherwise, it's going to be not a jailbreak. And again, that would be up to you kind of how to tune this and adjust what this score is. So now we called the cell, which has those functions and those decorators around them. Now, once we do that, all we have to do is reinitialize our schema with the LLM metrics in it. And now these custom metrics are going to be added in. So now if I profile with this ignore previous directions and do something else as the prompt, and if I look at that profile, and we just did the prompt in this case, that's why there's not the response over here. We can see that there's different ways to add them in, but in this case, the way we did it here, we just added them to this prompt column. So if I scroll all the way over, we have this vector similarity now in here, and we also have the label. So I can see that if I go over, this was, we just passed in 1 string here. So the max, the mean, et cetera, is all going to be 1 number because we just extracted from 1 prompt, but we can see our similarity score. And if I keep scrolling over, we'll also see that our label is added in as well, which in this case is, did I pass it? Well, we'll see it in the platform in a second, or how to extract it. But the label's in here where it says, jailbreak. Let's actually just look at it down here. It's a little bit easier. So here, we're going to access that data from that data frame or a profile, just like we've seen in the other ones, but now it's on our custom metrics. So we're looking at prompt, and then we're getting this UDF vector similarity max, and then the UDF vector similarity label, which in this case returned the jailbreak and returned the vector space there. And then you could write this to YLabs, and this is just going to go, I think, to our second profile, and it won't have a lot of data because we just did it on 1 thing, but just to show you what it would look like is now we had 33 features in here previously. But if we go look at our profile now, it's going to have 37 features because it added in the new ones with the similarity score. So we can actually see here prompt vector similarity and vector similarity distance. So again, this won't have a lot of data here, but I can see just for my 1 that it was not a jailbreak in this case. And then you could look at your single score here. And again, just like we saw with the profiles, this would look a little bit more interesting over time. But we get the median, the max, the min, et cetera from that. And I'm not going to run this, but I just want to also call out that we actually have an official LangChain callback integration. So if you want to write a little bit less code to send your data to YLabs, you can use this YLabs callback handler here. Just initialize it right before you call your LLM with LangChain, and then you'll be able to log the results even easier. So just as you pass them in to your model in LangChain, it's going to write them up. And then it's using something called a rolling logger, so it'll actually write them up. I think by default it's something like every 20 minutes, and otherwise you can call .flush and it'll write them up immediately. So if you did run this code, if you set your own API keys, etc., run this code because you're saying YLabs.flush, it'll push them up immediately. And then that's kind of all I have for the quick rundown today. I know it's kind of a crash course into a lot of stuff. There's a lot of stuff to explore further. There's more stuff in the YLabs platform. There's more stuff that LangKit can do. But I think I kind of showed you the basics and how to get started with it using OpenAI and LangChain. Hopefully this was super interesting and some of you had fun and learned something new. There's a lot more resources as well. So you can go check out these if you have the notebook open, where you can, find a whole bunch of examples in the LangKit GitHub repo, including another Get Started example, the LangChain integration. Go check out GitHub. That has a lot of stuff on it. And our YLogs GitHub as well. Again, we always appreciate a star. If you want to check out our other open source project that LangKit's built on top of. YLabs.ai, we have a lot of stuff going on there, including events all the time, almost every week. So if you're curious about just ML observability and responsible AI, there's a lot of cool events that we do. I do a workshop all the time. So like next week, I'm actually doing another one, not specifically around LLMs, but just monitoring AI models for bias and fairness with segmentation, which is something you can do with LLMs, but this one will be focused on a different data set. And then again, if you want the promo code, I'll just grab it from the slide real quick. If you thought this was interesting and you want to fill out the form for the enterprise version of YLabs, you can fill that out here. Otherwise, I'll hang out for just a couple minutes for any questions that I didn't get to. And again, let me know in the chat too if you thought this was interesting, if it was a tool that you find valuable, you're going to look at how to integrate it into your projects. I would definitely love to know. I know some people had to run to other meetings, which I totally get. That's why I have to leave in a few minutes as well. Yeah, but if this seems like something that, interesting and you want to implement it into your large language model applications, definitely let me know. And join the Slack channel if you haven't already, and you can ask questions there later. So if you are starting to implement this and you have a question about metrics or anything like that, ask in there. So some people were asking really good questions around like what metrics to choose and stuff. And again, I think it depends on your application and what you're trying to do. But that's going to be a good place to ask questions later too. And get input not just from me, right? Like other really smart data scientists and engineers are in there. Awesome. Well, if there aren't any other questions, I'm going to go ahead and end the stream. But please definitely ask them later, whether that's on LinkedIn with me or in the Slack channel. So I'm going to go ahead and wrap up the stream. Thank you again, everyone, for coming out. This was really fun. I know I loved showing off LangKit and using it with LangChain and OpenAI. So hopefully you found it interesting as well. And hopefully I'll talk to some of you later. Have a good day, everyone.